Hello everyone and welcome to Gamedev Pipeline Automation with Python Part 1. Today we're gonna be taking a look at a system that I realized for my thesis project, which was a first-person thriller video game that we developed in a team of 3 during around 8 months. Being the technical guy of a group and knowing that we were about to start a pretty big project for a team of only 3 people, I really wanted to give us every possible chance by finding and automating all the tedious and boring tasks that we possibly could. So I started looking at all the processes that we're about to start using for the production stage of the game, and I started by looking at Houdini, which I knew had a Python integration, which really was the only thing that actually allowed me to do this, because without Python it would have been impossible, of course. So basically I started thinking about what we could have possibly automated through Houdini. And the solution that I found was that, for example, we could have set up a pipeline where I receive the assets from the modeler, and those assets are then processed through a little file, Houdini file, so that we have the second UV channel that is needed for the light maps in Unreal, and then 4 level of details also needed inside of Unreal. The first thing that we're going to have a look at is the node tree inside of Houdini. Now, as you can see, it's pretty simple, because we're only taking care of those 2 tasks that I've just talked about. But the entire system, which also includes Python, is not limited to these kind of tasks. Inside of here, you could potentially have whatever you want. So as long as you have something that has a flow, so 1 or more input files and 1 or more output nodes, you can have like pretty much everything. So it's not about this type of processing, but it's about the automation of a task inside of Houdini. So let's start with a file node, which of course opens a file. Here we have a test model from our game. The first thing that we're doing is copying the attribute. We're copying UV onto UV2. So basically we're taking all of these attributes, the 3 parts of the UV attributes, and copying them onto the UV2 attributes, so that now we have 2 different UV channels. The second thing is taking that channel and doing a UV layout, so that to redistribute the islands a bit better, to actually allows us to then use them for the light maps inside of Unreal. So as you can see, this is the first and original UV channel that comes with the object. This is the one that we actually generated now. Then what we're doing is, right after this UV layout, we're having a raw FBX output, so that we can export it right away. And that is because the first level of detail, which is a 0, doesn't need to be reduced. It needs to be the original mesh with just the addition of the new UV channel. The other 3 outputs are instead connected to polyreduce, which is actually a node that decimates geometry, as you can see here. and it goes. You can put a percentage, and it decimates the geometry as much as you want. So basically, this allows us to generate different LODs which are then exported onto an FBX file of their own, with proper naming convention that we'll see in a second. But this is only the first part of our system. Now we're having a look at the Python code inside of Houdini. Here we have the Python source editor, which is a window that lets you edit and write code for example, the here Who.session module, which is the it's a module that gets loaded with a Houdini file. Every file has its own module, and you can use it to write some functions and some code that will be that you can later use in during your session, actually. So basically, if you need some helper functions or code that is useful to you when you are using Houdini, for example, you can put some things that have some setup scripts and whatnot, so you can put them here. You can run them from the the Python shell. You just have to call the whole module .session, as you can see here, which is a sub module, and from there you can for example call execute, and it will work. Let's start with taking a look at the code. The first line is an import, and here we're importing OS, Who, and HRPyC. Then we start with the only function inside of this piece of code, which is actually a function that executes the whole process, the whole automated task that we just talked about. The first thing that we need to do is get a string for the path to the folder, the input folder. And as you can see here, this is what we have here. Now, this system that we're talking about, this Python code and this Houdini stuff, was meant to be connected to a broader system that allowed me to have control over, to manage and track assets. So the first folder that we have here is modeled stuff that just came from the artists in my group, or I mean it used to be like that when we were working on the project. So basically this is our first folder where we have our input file that go and then are processed into this Houdini file. So basically, this path is relative to the location of the heap file. So for example, here we have it in pipeline script Houdini. It's this 17.heapnc, and it's a relative path, and it's not really the best, but it allows us to have I think it's better than absolute path. So yeah. This is the string that connects us to this folder. Then, right after that, we're listing the contents of this folder using the OS listdir function. The next step is then setting our input node. So we're basically doing input equals who_parm object pipeline script file1 file. This is a reference to this node, but specifically this field right here, which is called file. As you can see here, parameter is file. Once we have a reference to that, we can start the loop. So for every item in the list of objects that were in the folder that we found here, we're basically doing input, which is this field here, we're doing set inPath plus item. So we're basically taking the relative path to the file plus the name of the file, so that we can actually set it properly right here. Now, of course, as you can see here, now we're using absolute path, because I actually did it by hand here. When you pick it from here, it does absolute paths. But this would actually set a relative path that works anyways. So we basically, inside of here, we set the new file by saying, basically adding the path to the folder and the name of the file. Then we are doing a little bit of calculation to determine the kind of padding that we want on the object, and this is based on the bounding box. So basically we're doing, here we're taking the node, the input node, the file node, we're getting its geometry, and then we're getting its bounding box, and then calculating the size of that vector, which is bounding box. After that, we do an average, and based on that average, we determine the best padding value that we want to put in here. As you can see, the layout node as a field here called padding that actually allows you to describe how much padding you want for your islands. Then after that, we of course set the padding. So we go take the reference to the parameter here, padding, and we set it with this value, and then we are looping over 4 items. These items represent the 4 output nodes that we have. So basically we do an X range because we're in Python 2.7 here, not 3.7. So it's called X range instead of range, and we loop 4 times. Each time we determine a node, which is gonna be this string object pipeline script ROP-FBX, and then we attach to it the number of the iteration. So for example, the first iteration this will be I will be 0, and the result will be ROP-FBX 0, which actually leads to this node. So basically by doing that we have a reference to every output node during our execution. Then we set the actually we get a reference to the field, the output file field here, by doing basically we just do foo parm, and we concatenate node, which is the path to this node or all the other nodes, like the output node, and we add to that the SOP output string, which is actually the name of this field, as you can see here. So basically by doing this we have a reference to this field, which we then set with the name of the output file that we need. So basically we do an out, now out is this field, right? We do out set, and we set it with a path to the output folder, which in this case is called like this. This is our output folder. So basically files are taken from here, are processed, and then spit out in this folder. The name of the folder plus item.split. Now item in this case is the name of the file. By splitting it, we do item split on dot, and then we take the first part, and that allows us to actually get the name of the file without the extension. To that we add the LOD underscore LOD naming convention, plus the, of course, the number of the LOD. In this case, if it's the first iteration, we're on ROP-FBX0, and this will be called LOD0. And of course, then the .fbx extension. Now we have our reference to the node. We got the reference to the output field here, and we composed the name of the output file as we need it. Now we're ready to click on this nice little button, which is Save to Disk, and as you can see, it's called execute. So all we need to do is who-parm node plus execute, and then press button. Press button function will ensure that this button is pressed, not by a human, but like actually from Python. So this is our function, and it's all the code that runs in here in this Houdini file. The next and last thing that we need is to actually start an HRPyC server. Why is that? Well, as I found out working on this system, on this code, is that, well, coming to this point, I was like, okay, I've got the code, I just need to execute the code when the file starts. And given that I have it on who.session, it already happens, because, as I said, who.session is a module that gets loaded and executed every time you open a file. And it's per file, it's contained inside the file. So this didn't really work. The kind of errors that it gave me was, for example, this thing, and it was saying, for example, in who.session line 8, non-type object has no attribute set. And here, as you can see on line 8, I was trying to set the actual name for the input file, but it says non-type. I later found out that it was not the entire file was not being loaded, or at least it was not being loaded completely loaded by the time we started executing. So this would always execute before this was even ready, which is a bit of a strange thing. So I started looking at other options to do it, and for that I, for example, took the whole this whole tree and put it into a digital asset, for example, as you can see here. So basically I made a node out of it, and I then added here a script on the onloaded event. As you can see here, you got there's the operator type properties, which when you create a digital asset you can actually use to modify the functionality of your node. By the way, you can do it with any other node, but yeah, it's better not to do it on existing nodes, because you'll mess things up. Here you have a few options, well, quite a few options, one of which is the tab scripts. In the tab scripts you can actually have you can put scripts, of course. Now this is very useful, the event handler, and it allows you to have basically a script that runs whenever an event happens. So you can have stuff like onCreated, onLoaded, onUpdated, on all these kind of things. And basically what I did, I've tried to get an onloaded script and get all this code right here. All this code, I mean this code, okay, not just the function, okay. As you can see here, okay. So basically, here I have my digital asset, my unloaded script, and here is all that happens, or that should have happened when the file loads, which is basically a synonym of the Hoodo session, but I was just trying to find a solution and it didn't work. It didn't really work because it basically it behaves the same way. It gives you the same problem, and it says that there's a non-type. It basically doesn't load this in time for it to be executed by this. This runs before. And it kind of makes sense because these kind of scripts, initialization scripts, are mostly meant to set up the environment. They are meant to be initialization scripts that are run. The documentation doesn't specify whether these are actually run before the files is loaded or when the file is loaded. It's not really clear, but these are actually meant for example, a scene setup. When you say you open a file and you want some code to execute so that your environment is set up the way you want. It's very useful for that kind of stuff. And it's something that you can also access. You can access it from the Who session module. You can access it from the onloaded event on the digital asset, as well as these initialization scripts that I discovered thanks to this video, Houdini Python Masterclass. It's a fairly old explanation video about Python in Houdini, and it goes back to Houdini 11, if I'm not mistaken. And among the many useful things that it says, it also talks about initialization scripts. So I've also tried these as well. 123.py and 456.py, which are actually run when you start Houdini. The first is run when you start a blank session, and the other one is run when you load a file. So basically it was the same thing, and it also didn't work. So at this point I needed another solution. I started looking for another solution, and looking at the documentation here, this little help window inside of Houdini, which is very helpful, by the way. Every node that has its own little help window. In here I have found that you have also the Python documentation, which is where? Reference Python scripting, okay? You go Python scripting, then you would go for where is it? Yeah, here you have Home Cookbook, which is the Houdini object module inside of Python. And here you have a few guides that explain a bit how to use Python inside of Houdini. So basically what I've found here is that at the guru level, here you have this RPC page, and it's very interesting because it describes how to use the HRPC module, which is a remote procedure call, which is, RPC is stands for remote procedure call. Python on its own as RPC, which is its own version of remote procedure call, while Houdini has its own version as well, which is this actual one. So basically here, thanks to the documentation, I was able to do it in a different way. The way we're doing it here is actually we are defining the function here, as you can see, and then we are starting a server. We're doing hrpc.startServer. This opens a port on the local machine that allows you to connect externally to this Houdini instance, which is very helpful. As you can see here, you just import the module and start the server. Then what you want to do is then externally connect to this session. Okay, so this was very helpful, and turns out it actually worked. But in order to do this, I needed to write some other code, and this is where we talk about the rest of the Python code. This is my main module, which was meant to be the starting point for all the automation that I wanted to do for this project. And it also contained a few functions that helped in asset management, and that were mostly, sadly, unused. I didn't have time to finish all of this, but let's see what we actually care about for now. So this is the function that we run in order to run all of this stuff here in Houdini. It starts by removing the files that are not what we want in this folder. So the input folder, which is this one, is checked for files that are not FBX, because we only want to process FBX files, and another file extension will break the whole script. So after removing the files that are not inherent to what we want to do, we list the contents of these two folders. The first folder, which is the input folder, and then the output folder, so that we can compare it later and we can check we can check if the script executed properly. We can check if it worked, okay, by comparing what we had before and what we had after the execution. We can be sure that everything worked. But that's not what we care about. The next thing was then to actually, it's pretty simple. We need to go on a command line, go to the right folder, which in this case is relative to this script, which is in this folder. So up and it's in, where was it? We wanna, this is relative from the Python binaries. So we're using Python 3.7 here. So if you start it from here, the path is up one, and then you delve into the Houdini folder. And all you want to do is just open this file. By opening this file, this code will be run. So you're gonna define the function and then start the server, which is exactly what we want. So basically, this worked and was enough to have Houdini up and running with the server open and listening for our connection. What we also needed was then connect to the HRPC and tell it to start the execution. Now, in order to do this, I needed Python 2.7, because Houdini, as of the 17.0, still runs on Python 2.7. So basically it was incompatible with 3.7. I could not, and I've tried, I could not import the HRPC module inside of Python 3, because it just doesn't work. It's written for Python 2. So what we needed was then call a function, which is launch Py27 script, which is which the only thing it does is just open the command line, go to the Python 2.7 folder, binary folder, and execute it. and chain the file that we want to execute. So basically this is a one-liner that on the command line will move to the right folder and execute the Python exe with the file that we want, which is a Python file, of course. The file that we want is actually this one, who27.py, and is the one that is taking care of talking with Houdini. In this file we import thesis because we need to append the paths to the Houdini Python modules, which are these two. And then finally, once we imported those, we appended those in the path of our import path. We can actually finally import HRPyC. Now we can use this line, which was actually written here in the documentation. Here, this one. To actually get our hands on the connection and the session that is running inside of Houdini, which is simply like connection and who equals to hrpyc.import remote module, and that's it. Now we have who, which is a reference to the actual Houdini session. And we can simply say who.session.execute. By doing this, we will call this function, and that will actually do all the things that we've already seen. Then, after that, we say, here we had like who.apefile save if we wanted to save the thing, but that's not what we wanted, because it actually asked you, I think it popped up a user prompt that we didn't want. Of course, we wanted it to be as automated as possible, so we then we exit Houdini and suppress the save prompt. And with this file we're done. This is the bridge that allows us to go from Python 3.7 to Python 2.7, so that we can actually run all of this code here in my main program, my asset manager, on 3.7, because that's what I want, and then connect back to Houdini through Python 2.7. The last two things that we do here are then checking the results of the process by comparing the list of files contained in those two folders, in the input and in the output folders, so that we can we compare them before and after the execution, so that we know pretty much exactly what happened and if everything went right. Then the last thing that we do is move the processed meshes, the input actual meshes, from the input folder to the archive folder, so that we just take them out of the way, so that we know that they were processed. And that's it. Another thing worth noting is that I had to use threading. Now, why is that? Well, let's have a look at this piece of code here. This is what all I was doing here in this part of my function. I was just saying last system, and then cd to the Houdini folder and execute the Houdini file. What this does is that it opens a command prompt, and from that command prompt it writes into the command prompt the commands to actually open Houdini. So by launching this in Python, by executing this in Python, it launches command prompt, which launches Houdini. Now, the command prompt doesn't close because Houdini is still open. So until the command prompt doesn't close, this doesn't return, and the execution of the program is stuck. So it took me a while to figure this out, but I then realized that I could use the threading module to basically define a thread, which target is a lambda function containing my code. This is what I care about. So defining that thread, I can then start that thread. This thread will execute this function and will actually open up the command prompt, will open up Houdini, but will not stop the execution of the program. This doesn't return, okay, until it closes. But since it's on another thread, I can now go ahead with execution of my program. So now, in order to execute all of this, you would need to launch Python, import this file as a module, and then call this function. And then all of this happens. So, now that we've done all of this, how is it supposed to work? How am I supposed to use it? How am I supposed to launch it? Well, let's see, you need a Python, and in my case I had a portable Python, so I'm just gonna go to that folder and launch the executable. In Python, we wanna import and execute this module, actually this function inside this module. Of course, doing it every time it's a bit tedious, but you know, it's something that you can code, for example, inside an actual Python program. For example, as it was meant to be in my case, I was meant to have a proper program that managed all the scripts and used this main module as a base file to get functions from. Let's say you have your Python open. You first need to import sys so that you can then do sys.path.append, and you append the folder containing the script that you want to import. In this case, since my Python is in here and the script is this one, the module, actually the module is this one, I will do sys.path append and I will put in 2 dots. This allows us to then do import main module as mm, and now you can see that mm is my this file imported here, and from this you will do mm.run who and call the function. And I'm back. So it turns out that in this file I had the relative paths actually relative to this folder and not to this folder because I was using them inside of another script. But okay, let's go ahead. Now we have everything ready here. I am gonna say that it's not gonna output any file because I don't have a right license to do so. I cannot export FBX with the apprentice license, but that's beyond the point. Let's see how this does. It launches Houdini. Now it has a 10-second delay, and it loads the thing, you can see the errors, and it closes. And that's pretty much it. Now, of course, here it says that it cannot move the asset from here to the archive because it's already present, because that's something that I've reused from the old project. But yeah, that's it. So in order to make these 4 lines, this is how you call it from command line from Python. In order to make it even more streamlined, you would need to connect to put it in a bigger program. Maybe something with an interface, like for example, as I was trying to do here, you could build an interface with Qt Designer and then connect the function call to a button, and it just it just works without having to write all of this. So I hope that was clear, and if you have any questions, you can write me to the email address in the description.